we got some plans here. We got 3 routers with some addresses, and I'm going to show you the ways of assigning IP address to an interface first. Later, I'll take you to the routing stuff. If you notice on router 1, I have a loopback interface with 128 address, meaning fully masked, which means I have given the complete 128 bit. The global prefix as well as the interface prefix, and the colon in the middle represents 6 sets of zeros. Now, likewise on R3's loopback and R2's loopback. But on router 1's Ethernet 00, okay, even in there, I have 64 bits /64, which means only 64 bits of this address is global prefix. The balance 64 is interface prefix. So balance prefix is sets of zeros and last bit is 1. Whereas on R2, Ethernet 00, you are not seeing me giving the complete address there. You can see only 2000:12. What happened to the interface prefix? Interface prefix we are not giving here. Instead, we are saying take the MAC address and extend it to 64-bit. Use it as an interface prefix. That's the meaning of this EUI64. I repeat, the first 64-bit is given. You see, after the colon, there is no number, which means the interface prefix is not given. Here, I have given ::1. 1 is the interface prefix. Whereas on router 2's Ethernet 00, the interface prefix needs to be dynamically generated and attached using MAC address on that port. MAC address size is only 48-bit. What is the size of interface prefix? 64. Then what is the difference? 16-bit, isn't it? 16-bit difference. When you take a MAC address, it's going to be only 48. But how many you need? 64. Do you understand what I'm trying to say? If you say, okay, we are asking the interface MAC address to be used as the interface prefix. What is the size of interface prefix? What is the size of MAC address? No, MAC address. Now, how many bits I need to make as a 64-bit address? That's what I was saying. See, MAC address is taken, 16 bits get added to make it as a extended unique identifier. EUI means what? Extended. I'll talk about that. Please wait. You see, I'm trying to explain you how you get that 64-bit. You cannot simply use the MAC address because MAC address is not 64-bit. MAC address is taken. Additionally, 16-bit is added to make it as a unique identifier after extension. That's why it is EUI, extended Unique identifier. What is MAC address? Is it not a unique identifier? It is. So, good question. You were asking, like, from where the 16-bit come? Or you can also ask the same question like this. What is that 16-bit added? It is right to the middle of the MAC address, right to the middle of the MAC address. FFFE is added. I repeat. Let me copy one MAC address example, or let me type one MAC address. MAC address will be like this: ABCD colon or dot. Oops, 1, 2, 3, 4. Just simply randomly typing. This is how a MAC address will look like. 12 digit, isn't it? Hexadecimal. Right in the middle, you see? Right in the middle. Means after 3, FFFE is added. Now, instead of dot, you get colon because it is IPv6. That's it. Always FFFE will be added to the middle of the MAC address. You understood? Always. There is no other hexabits added. It's only FFFE. Okay, now that is the meaning of this one. Now let us move on to this other side of router 2. On the other side of router 2, if you notice, I have given the complete address. Yes or no? Complete address. What is this DAD? DAD is the global prefix. What is the 2? After colon colon, the 2 is interface prefix. So I have given both the network portion as well as the host portion. Now, what about router 3? Router 3 Ethernet 00, I'm not willing to give any address. I'm not willing to give any address. Instead, I ask router 3 to auto-configure. You see, if router 3 needs to ping router 2, the address on router 3 Ethernet 00 should start with DAD, isn't it? So let me repeat to confirm. If router 3 needs to ping router 2, the address on Ethernet 00 of router 3 should begin with the same network portion that you see in router 2's Ethernet 01, which is DAD. Now, if I tell to router 3 auto configure, how router 3 knows to which network I need to join? You understand what I'm saying? No, there is no CDP neighbor here. Oh, so router 3 needs to have an IP address auto configured that matches the same network portion that of router 2's Ethernet 01. If it is DHCP, then we understand how it will work. But here there is no DHCP. This we call it as stateless auto configuration. Why it is called a stateless auto configuration? SLAC. SLLAC. Why it is called a stateless auto configuration? It is because the DHCP server is the one who makes stateful is no more, is not present. Okay, now what is that we are going to do now? We're going to assign IP address, then we'll talk about the other things. Uh, so let me complete this one. How is this auto configure work? You see, if this router 2 is in a router mode, meaning if router 2 is ready to do routing for IPv6, usually what router 2 will do, it will send neighbor advertisement NA. You are talking about CDP, right? But CDP is not needed here. Router 2 will use a multicast address and it will do neighbor advertisement. That makes router 3 to understand to which network it needs to join. So it learns the address of router 2 even when there is no IP address in router 3. How is that possible? It is possible because of link local address. I told you there's an address for neighbor discovery called link local address. Do you remember how the link local address looks like or how it begins? FE80. FE80. I'm sorry. So the link local address is more than enough for router 3 to communicate, for router 2 also to communicate, which makes router 3 to understand router 2's network portion of the global unicast address. Right? I'm going to quickly show you these things. So here, okay, we are happy that the router is blank, nothing configured, it's fresh. Okay, now I'm in R1, host name R1, interface loopback 0, IP address IPv6, address 11111 slash 128. Next, interface Ethernet 00, Moshat, IPv6 address 2000 colon 12 colon 1 slash 64. Now, if you check show IPv6 interface brief, you can see these two address receiving a link local address starting with FE80. Did I configure this? No. And if you notice that link local address, FE80 is in the beginning, but the final 64-bit is actually made out of MAC address. You see here, FFFE is added in the middle. And this is the MAC address on this interface. All right. Okay. Now, what about the loopback? Loopbacks are logical interface. They don't have MAC address. They usually copy the MAC address from the physical interface. We have right now only one physical interface. Usually, it copies any MAC address of any physical interface. So it has copied the MAC address of Ethernet 00, which is right now active. Now, is it okay to have same link local address on a router? Why not? No problem. What you should not have is, you should not have the same link local address on the other router. That is not acceptable. Hmm. You, again, it copies somehow the MAC address from the physical interface. Let me show you here. Look at this, an R3. What I'm going to do is, I'm not going to configure the physical interface. All right. I go only to the loopback, as you said, IPv6 address. Okay. Now, even now, you will see a link local address for this loopback. I know it is going to take a MAC address of the physical interface. Again, even if it is inactive, it can copy. Show IPv6 interface brief. You see. Now, when I go to this interface and say no shutdown, nothing will come. No shutdown brings the interface up, but will the link local address come? No. Sorry. When will the link local address appear? Two options. No. That is see. After you assign an IP address, the link local address will come. After you assign a global unicast address, the link local address will come. Or if you configure the interface to auto configure the IP address. You see, I told you to get the auto configured, to get the IP address auto configured, it needs to communicate. It needs an address. And I was telling you the link local address will be used for the auto configuration. Did I? Yes. So right now, it's not showing you, but when I go to the interface and say IPv6 address, I'm not willing to give you any address, you simply auto configure. After I say this, if you go back and check, you will surprisingly see the same link local address, which means loopback interface has copied the MAC address of Ethernet 00. So instead of saying the active interface, it copies the MAC address from active interface. Instead of saying that, we can say it copies the MAC address of the first interface, even when it is down. Even when it is down. But that doesn't matter. The reason is you can have all, you can even have all interface with same link local address on this router. It will not create any conflict. Only thing is you should not have same address on the other end of the link. See, this is the link local address. The scope of the address is only on the link. You got the point? The scope of the address is only on the link. So in two links, if I have same address on the same router, no problem. But on the same link on the two edges, you cannot have same address. It's going to conflict. Okay, now let us move on to router 2. Router 2 right now don't have any address. Hostname router 2. Interface loopback 0, IPv6 address 2222::2222. Interface Ethernet 00. Now I told you on Ethernet 00 I won't be giving full address. No. I'm in E00. Please focus. I said on E00, I won't be giving this interface the full address. I'll give only the global prefix. I'll be giving only the network portion of it. Okay. So 2000 colon 12 colon slash 64. And then I'm saying EUI 64. You understood? Now, if you go back to the interface and check, sorry, not go back, if you go to the interface and check show IPv6, interface brief, you can see here the MAC address is taken, same like what you see here in the link local address, and it is used as the interface prefix. That's all about the EUI 64. Now let's move on to the other side of this router. Interface Ethernet 01. Config the interface Ethernet 0/1. And here I'm going to say IPv6, no, shut down first, and then IPv6 address, DAD. See, this is not a case sensitive. It's insensitive. It's case insensitive. So you can type this 2 slash. Okay, now we have this routers with IP address, show IPv6 interface brief. We have this IP address, you say DAD colon 2, but will there be an IP address on R3? Will there be an IP address on E00 of R3? No. Why no? For that, router 2 need to be a router. What do you mean by a router? Is it not already a router? No. For IPv4, this is a router. For IPv6, the routing need to be enabled. You understood? So how do you prove that? If you now go to show interface Ethernet 01, you can see, oh no, I should have typed this command, IPv6. Show IPv6 interface Ethernet 01. You can see it has joined a multicast group called FF02 colon 1 only. What is colon 1? It is equal to 224.0.0.1. In IPv4, what is 224.0.0.1? It's a host multicast. Host. It is not a router multicast. Okay. A router multicast is FF02 colon 2. In IPv4, it is 224.0.0.2. It's just an all systems multicast. We need all routers multicast. Meaning it needs to be a router to provide the service. Right now, if you go to router 2 and check, you still didn't get any IP address configured. No IP address auto configured. Now, I would like to enable some debug here so that you can see how this R3 gets that address configured. Are you ready? IPv6, debug IPv6 neighbor discovery. And next one, debug IPv6 packets. Debug IPv6 I think there's no more needed anything else. Enough. Now I'm going to go to router 2 now and say this command. Ready for this? IPv6 unicast routing. See, if you don't type this command, this router will be considered as a host. So when I hit this enter, two things happen for you in today's lab. You can enable routing protocol. It won't throw error. Without this command, if you try configuring any routing protocol, it won't allow you to enable any routing protocol without this command. Secondly, for the auto configuration, this is needed. Shall we go and verify? I'm going to hit enter. I hit enter. Now I take you here. Look at this. Look at this. R3 already knows R3. R3. Let me stop this. See, router 3 already received a prefix. Router 3 says, I will be having this as my prefix. You understood? How it knows? It knows through this neighbor discovery. Okay, you see, the prefix is DAD, colon, colon. It is received through neighbor discovery. ICMP version 6 is giving this. Okay, now let's go down here and also after this, please pay attention. After this, router 3 has also said, okay, listen, this is the network portion, and I have taken my own MAC address and I have built my own address. You understood? And it has found it as unique. No one else have got it. How it knows? It knows that there is no other duplication through the address manager. Address manager will do duplicate address detection. It will check whether there is any duplicate, and there is no duplicate. So router 3 has declared to use this address. Show IPv6 interface. You look at this. Yeah. Now you can ping from here DAD colon colon 2. You can ping the other router. You can also ping from there. You can also ping from here to there. Okay, so now we have learned how to assign IP address in different ways. Next, we are going to do static routing. Then you need to have another router here in between 2 and 3 connecting through a switch to supply the network portion. See, someone should be taking responsibility of providing the network portion. You cannot have both the side auto config. I totally understand your question. You see, you can have 1 million computers, no problem. In that 1 million computer, you need to have at least one router. You need to have at least one router which can provide the network portion. What I'm trying to say is, you can have any number of routers, auto config, auto config, auto config, auto config. At least one should have the network portion with routing enabled. You understood? Now, are we ready to go to next static routing? Okay. In IPv6, You cannot say the exit interface. If you want to say exit interface, you should say along with the gateway address. See here on router 1, show IPv6 route. You don't have route to reach the faraway network. So I cannot ping from here DAD colon colon 2. What? DAD, where am I? Router 1. DAD, okay. It is using this one, neighbor discovery. I did not write this. It writes by itself because this is seen as a host. R1 is seen as a host. Let us make it as a router. IPv6 unicast routing. Okay, now it's a router. Now let's see. See, it's gone. You understand? Now, if you try pinging DAD colon colon 2, not possible. You need to write a static route. See how IPv6, very nice. It gives the default gateway to all the hosts. R2 was the only router, but now I made R1 as also router by putting this command IPv6 unicast routing. Isn't it? Router 2 was the only router in the topology. So you are getting a default route, like a default gateway on a computer. R1 was having a default gateway, and it was pointing towards the link local address of R2. Now, it's a router, you can't ping show IPv6. There is no route. Let me also enable routing on R3. IPv6 unicast routing. Okay. Now, on R1, I'm going to write a default route. It is. Because R1 is a stub router, is it not a stub router? We can write a default route. This is how we write IPv6 route colon colon slash 0. This means any network, any subnet mask. Colon colon means what? All zeros, isn't it? And the mask is also slash 0. Now, don't say Ethernet 00 and enter. If you want to say interface, you also need to say along with the gateway. Okay? You should not simply hit enter. You should either say both or the gateway address. I do not know the IPv6 address of router 2. Let me copy from there. Show IPv6. This is the address. Okay, so this is mandatory. The exit interface is an optional one. Okay, now default route is written. Let me show you. Show IPv6 route. You can see a static default route. And now if I ping the DAD thing, it will ping. You see it's pinging. And you can see not even a single packet lost, even when it is the first ping, there is no single packet lost. How? Because the neighbor discovery, see? I show IPv6 neighbor discovery. Show IPv6 neighbor. You see, it has already learned the MAC address of the neighbor. Before you ping, no, it will learn. I showed you the debug. It was sharing all this information, isn't it? Using ND, neighbor discovery packets. So now I'm able to ping from R1 to R2's loopback. Let me try pinging from R1 to R2's loopback now. Earlier I was pinging DAD colon colon, and now I'll ping. I'm able to ping. Okay, but I'll not be pinging. See, it's unroutable. Yep. Show IPv6 route. There is no route to reach 111 colon 333 for router 2. Router 2 do not know about it. So router 2 has given you a message unroutable. Who gives you this message? It's router 2 giving you the message. Yeah. Now, router 2, I'm going to write a static route. On router 2, I don't have route to reach 1111 colon 1111 colon 3333. So how do we write static route? This is how we write IPv6 route. I'm going to say if it starts with 1111 colon 3333 slash 128. If it is like this, then send it to 2000 colon 12 colon 1. And likewise, oh no, I made a mistake. It's not right an address. So actually what I mean is 1111 here. Yeah? Is it clear now? Okay. Now let us do it for this one. This one, the gateway is router 3's address. Let me go copy the address. Show IPv6 interface brief. This is the address to which we want to send. Boom. Right, now let's go verify. Show IPv6 route. You can see here there are two static routes. And now if you try pinging, you will be able to ping. Yeah, to ping. Now on router 3, I'm going to write a default route. That's it. Now I can ping from anywhere to anywhere. Let me try pinging now. Ping 1111 colon 1111. So loop it. It's pinging. Yep, it's pinging very well. We have seen how to write a default route and a static route. Now, I would like to tell you a very important message. What it is. You can have both IPv4 and IPv6 on the same interface. Say, for example, show IPv6 interface brief. You have this address, isn't it, on E00. Now, if you want to have interface E00 with IPv4 address, very well you can have 10.10.10.1. Nothing wrong. Show run interface Ethernet 00. You see, you have both IPv4 and IPv6 address. Another thing I want to show you is I can go to that interface and say IPv6 address AABB colon CCDD colon ABC colon CBA. Okay, DP, no, CBA slash 64. What I'm trying to show here is when you put a new address, it will not override the old address. Look at this. So you can have more than one address on the same interface, which is not possible in IPv4. No, both are primary. In IPv4, it is not possible. When you write another address, it will override the old one. So remember, wait. Remember, if you are making any mistake in typing IP address, make sure you remove the address before you put the other one, because you may think that in IPv4, when I put another one, it will override the old one. But in IPv6, that's not the case. The old address will be still there. Okay, what was your question? No, because R2 don't have the same subnet. What I'm trying to say is, if you have it, if you have the same subnet on R2, then it is possible. Here I'm going to say AAA. Now, if you try pinging from here, that address on the router 1, I'm able to wait. Don't put 64 here. See, not even a single packet lost. And if you have a default route or static route, you will be able to ping. Now let me go to router 3 and try pinging the same. You see, hey, come on, don't put 64J. See, you're able to ping. So it pings this address as well as 2000 colon 12 colon 1. It's the same interface responding you. Now, is this a good one or a bad one? Is it an advantage or disadvantage? It is an advantage. You don't need to spend two separate interface to connect to two ISPs. Easy, no? You don't need to have two separate router or two separate interfaces to connect to two different ISPs. If I have two ISPs and connecting having BGP, I'll get routes from both the ISPs on the same interface. That is easy. You have a switch in the middle, and the switch is connected to two ISPs. Router connecting to switch connecting to two ISPs. Yeah. Put all these three interfaces in same VLAN. Finish. Okay. So it's a very good one in IPv4 to achieve this. Either you need to create sub interface and have trunk configured on the switch. Sorry, it was a difficult one. Mm, mm, mm. Yes, we're going to discuss those things in our next class. We can. So your question is, in the LAN you have IPv4, on the WAN you have IPv6. Okay, that is also possible. The other way is also possible. In the LAN you have IPv6, in the WAN you have IPv4. That is also possible. Okay, it is called dual stack. It is possible. Okay, now we have seen how to configure static route and default route in IPv6. I'm going to quickly remove them. Show one section IPv6. Okay, now where are we? We have to start configuring a protocol to learn routes. Now we'll start with RIP. Are you ready for that? Right now, if I try pinging the addresses which I used to ping early, the ping should not happen. It's not happening. Show IPv6 protocol don't show me any routing protocol. Now I'm going to enable IPv6 RIP. Actually, you don't need to go to the global mode. Not necessary at all. You straight away go to this interface and say IPv6 RIP, give a name, kangaroo. Enable. Kangaroo is an animal in Australia. I enable. It's just a process ID. Kangaroo is a process ID. Show IPv6 protocol. Now you can see a protocol called RIP running on these two interfaces. I'm going to go to router 2 now. I repeat the same process. Interface, range, loopback, 0, Ethernet, 0, 0/1. IPv6, RIP. Dear, enable. Now, RIP is enabled here. You see, this is just locally significant process ID. That's what I want to say. There I said kangaroo, here I said deer. Huh? Show IPv6 protocol. You can see here these three interfaces. Now, if you check show IPv6 route, you can see some RIP routes. I'm able to ping. Boom. So, do you want me to do this on router 3? Okay, fine. I'll do it. Okay. 3 interface range loopback 0, Ethernet 0. IPv6 RIP. Give a name of a rabbit. Anyway, done. Now show IPv6 route. You can see all the routes learned. RIP. Only the RIP learned routes. And I'm able to ping this with my own source. Not even a single packet is lost. It's not like an IPv4. Before you ping, the readiness will be there. They discover. What is next? We are going to remove RIP and we are going to put AIGRP. So removing is very simple. No IPv6 routing. IPv6 unicast routing. This removes all the routing protocol. And then I put the routing back. Show IPv6 protocol. There should not. What? Show IPv6 protocol. There is nothing. Yeah, there's nothing now. Now, I do the same thing now here. No IPv6 unicast routing. Yeah, show IPv6 protocol and also on router 1. Okay, show IPv6 protocol. There should not be any protocol. Show IPv6 route. There is no route other than the directly connected. As we discussed, we are going to enable EIGRP. Remember, I was telling you in EIGRP, you should not forget to say no shutdown. No shutdown is a very important thing that you should not forget because it's not normal, Usually we say no shutdown to an interface, but here it is a little bit, I don't know, you can call it as weird, or I don't know how you call it as. For protocol, you have to say no shutdown. That's the very important thing. Second thing is the router ID need to be there. If you are not ready to give a router ID, 32-bit router ID, it's okay. If you have an IPv4 address, it's going to pick. But right now, I don't have any IPv4 address, do I? Show IP interface brief. Okay, I do have some address. So this address will be taken as the router ID by EIGR. Okay, this is the command IPv6 EIGR, IPv6 router EIGRP 100. And I'm not going to say router ID. If I want to say, I'll say EIGRP router ID. If I want to say, you can say, let me say. And then forget not to say no shutdown. But you should do it on interface now, after this. Now, interface range loopback 0, Ethernet 00. Now we have to say IPv6 EIGRP 100. That's it. Now EIGRP is running on these interfaces. Let's verify show IPv6 EIGRP interfaces. You can see that EIGRP is running on this two interface and it belongs to autonomous system 100. Let me do it on router 3 now, 2. If you missed something, you can understand here. But for a change, I'm going to say go to the loopback interface. I put some address, IPv4 address, so that I no need to provide a router ID. You see, if you go back to router 1 and check show IPv6 protocol, you can see a router ID being used. IPv6 routing protocol uses the IPv4 syntax router ID. Means 32-bit ID. See, the K values, everything is same like what you learned in IPv4. The variance. Max path is 16. There you saw 4. Here it is 16. Now, what I'm going to do is I'm going to go to router 2 and say IPv6 router EIGRP 100 and then no shutdown. I'm not giving router ID because it will pick from loopback interface. I want to show you the interface range loopback 0, Ethernet 00-1. IPv6 EIGRP 100. Boom. Look at this. I told you the link local address is used for neighbor discovery. You see? Neighbor discovery. EIGRP also uses the link local address for neighbor discovery. You don't see any 2000 address or DAD address there. You see a link local address, FE80. Neighbor is established, show IPv6 route. You can see dual algorithm. And you see the next hop is the link local address. Let me go to router 3, do the same thing. IPv6 router EIGRP 100, router ID, EIGRP router ID 3.3.3.3, no shutdown, interface loopback 0, Ethernet 00, range command. IPv6 EIGRP 100, finish. Now you see I can ping from here 1111:1111, the source loopback. Show IPv6 route EIGRP. These are all EIGRP learned routes. And the administrative distance is same like what you saw in IPv4 90. Show IPv6 EIGRP topology. You can see the topology there. Yeah. Right. I think we'll stop